So as promised, here's the case study. And to put it as briefly as I can, this green screen at the back is a very obvious presentation of the data that's in the HR employees table. And let's say we've decided we don't like it very much because the phone numbers are represented in a single column in a somewhat asymmetrical fashion. For people within the US, it's just the naked 10-digit number that's used there. For people outside of the US, it's presented with the the digits you use to get an international line, and then the country code, and then the number itself. That's asymmetrical. Let's say we prefer to refactor, in the sense that I use that term, the data, so that the phone numbers are represented in two columns in a very straightforward fashion. Country code, and then number within country. Never mind that I didn't bother on that slide and in the code that I wrote for this, but you won't see that today, to fake up a variation of format within the country. I'm sure you can believe that it's quite possible to compute a transformation from the green representation of the phone in one column to the purple representation in two columns, yes? You could probably all manage to write it. Bit of if-then-else-y sort of logic going on. You know, does the thing have 0 1 at the front or not? If it does, then the next item in it is going to be a country code, on and on and on. But it's very doable, and whether you manage to express it in one single SQL statement with case or decode or who knows what, or whether you prefer to do it in a bit of ordinary PL SQL, I don't know, but it's very doable. So then, that's our scenario, and this is the full-on hard shell, the full-on thick database, smart database approach, and therefore we can imagine that there's PL SQL in the database too, and that naturally, in the green world, it reflects the fact in its structures and in its API to the outside world that phone is a single quantity. And after, it's got to be rewritten so that phone is a double quantity. So that's sufficient, you know. Our upgrade requires us to change the structure of a table and refactor existing data, and it requires us to change the code in the database that manipulates that. Simple as that. But that is everything we need to motivate the whole understanding of how EBR works. So we're going to go through it in this order. First, I'll explain addition, then additioning view, then cross-addition trigger. And though I put up that scenario, I will talk about a subset scenario when explaining the addition. Now, bear with me. Though I said, and I've been saying all the time, that data is critical in this picture, blah, blah, Golden Gate, blah, blah, transactional, right? Nevertheless, I'm not going to address that part of the story at first. So when I talk about the notion of the addition, you might feel, wait a minute, this isn't enough. I don't see how this works. And of course, you won't see how the big picture works till I do the next bit. But I have established beyond doubt by experiment over time that there's only one way to get across these concepts, and it's to begin with the addition. And to do that, it's enough to imagine a completely simpler scenario where this is the aim. It would be very clear in downtime what you do. Let's assume you've got 1,000 PL SQL units in the database. Actually, I could have said 1,000 objects whose kind is either view, synonym, or PL SQL. But just to save breath and say this in a more compact fashion, let's assume that the objects of interest are PL SQL. And you know, packages, to save breath. You've got 1,000 packages, right? And what the present exercise is just to change 10 of them, right? That's what I've got on the bottom. And in other words, if you did this in downtime, you would simply run 10 create or replace scripts with the definitions of the packages as they should be in version 2, and you've reasoned and tested before you run these scripts in production that you don't have to touch the source code of the remaining 990, okay? They might go invalid transiently, but you have worked out that if you just press the big util recomp button when you're done, everything will sort itself out. And by the way, this is the general case, so the objects are distributed across more than one schema. So in pictures, I'm sorry, there's a typo there. I can't take 10 from 1,000 and get 999, it seems, but you know what I mean. That's the aim. And now just imagine this kind of thought experiment, this scenario. This is your task, and then your manager or manager above you insists that it be done with 0 downtime, and just to annoy you all, he or she also insists that for some whimsical reason, you're not going to be using EBR, right? Who knows why, but you're not going to be using EBR. You just got to find a way to do it. And this manager might say, clearly it's possible, otherwise these EBR people couldn't have done it. You just work out what they've done and you do it, right? So, easy enough. So now I'm just going to talk. I don't need the words on the next slide, and when the next slide comes, I'll skip over it. Imagine how you and a couple of colleagues would brainstorm this then. The first thing you would realize is that you want to change, you want to do create or replace on A, B, C through to the 10th letter of the alphabet. The next thing you realize, of course, is the very first one, create or replace package A, blah, 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 blah. You can't do it, because if you did it, things would break. In this case, it's dramatic, because it's not until you've changed all 10 that you've got a consistent definition again. If you change only one, things have gone mad, you know. What can you possibly do then? There's only one thing you can do, which is instead of going create or replace package A, blah, 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 you have to go create or replace package A primed, yes? That's all you can do, or A2, let's call it. When I say A2, that's just shorthand for Scott.v going to Scott.v2, or if you prefer, Scott.v going to Scott2.v. I don't mind, but you can't have Scott.v going to Scott.v. Those two quantities, Scott and v, are used up. You've got to do something to distinguish this separate, secret occurrence from the one you still have in operation, yes? So it doesn't seem that hard, you think, and then you move your attention to B, create or replace package B2 as blah, blah, blah. Simple, this. Go to C, blah, blah. C doesn't compile. Why? It would have compiled perfect. C2 doesn't compile. It would have compiled perfectly happily had you just been doing the thing on classic methods offline. The reason is obvious, of course. When you look at the source code of C2, as it's now become, you notice there's a reference in it to A and B. That's natural enough. But you changed A and B by, intention in some semantically incompatible way. So the old A and B are not the A and B you need. You need the changed A and B to make the C that you've written the source text for to work. So now you realize, oh, I have to change the spelling of A and B into A2 and B2. Well, how hard is that? So that's what you do. You can imagine then that you get through the first 10, A to whatever the 10th letter is, with your A2 and B2 and so on up to, let's call it J2. Obviously, you notice that you've done a lot more code changes than you would have wanted to, and the code is looking a bit ugly now because you've got all these 2's all over the place. Are you done? Is the question. And I guess you can guess, though you're all too shy to say, that the answer is probably not. And if you did a sanity check read-through, even if the rest compiled, which in this example, by design of what I said, they would, you notice that, oh, wait a minute now, there's references in the text to A in some places, B in the other, and those are the old versions, yes? So that's no good, even though in the downtime time, all the rest of it would have needed no source code changes because you designed it that way or you knew that was the outcome. Now, to get the functional changes that you made, you realize you have to make renaming changes in the remaining 990 that you otherwise wouldn't have had to do. And you can imagine this is like pulling a thread on a Norwegian jumper. It would go on for 2 months and you still wouldn't have finished all that loving done up in the mountain knitting. And eventually, of course, you know where this is going. You don't, in the general case, declare victory until every single one of the 1,000 has now a new copy of itself with a suffix on the end to distinguish it from the original one, yes? And are you finished now? No, of course not, because at least among that set of 1,000, some of them are referenced by code outside of the database. So now you can see that while in principle, I suppose it's doable, in practice, it's just utterly unacceptable because of the vast amount of code changes that you would have to do. And by the way, you'd have to have everything doubled up in the database. Maybe that's not such a problem for code because it's not so big, but nevertheless, you notice that you're explicitly copying everything. So in summary, what's the pressure? What's the thing that's stopping you do what you would so much like to do? I think you can see by the way I set it up, it's that the naming mechanisms, without the wonderful magic of EBR, are not rich enough to support the game. It's as simple as that. So if I say it like that, it's blindingly obvious what EBR brings in the form of the addition. The addition is clearly some scheme that extends the naming mechanism, right? That was a challenge. EBR is the solution. So the solution must be to extend the notions in naming. So before the advent of EBR, objects were just identified ordinarily by name and owner. And we'll come to that point in a second. After it, there's more to it, of course. So this is where I switch now. This is the moment we start. This is the real teaching. And all the rest was stage setting. And even now, I'm going to be a little bit kind of wordy and stress all this conceptual business. What I'm giving you here now is a set of axioms. And they're the axioms that characterize a conceptual invention. And this conceptual invention was invented by a small team of people in Oracle headquarters. I was lucky enough to be part of it, out of thin air, you know. We didn't have anything that would meet the problem. We knew in general terms what it should deliver, but we needed to be specific now. So we had to invent it. And we didn't start by thinking about, you know, C code and internal implementations. We began by thinking how it would manifest to the programmers such as yourself who would be using it. And we came up with all manner of schemes, and some of them seemed initially quite appealing because not only did they seem to meet the goals that we clearly had to meet, but they gave other benefits as well, you know, like wake up in the morning with a cup of fresh coffee or something like that. And it's always attractive to get something extra from your solution. But guess what? You can imagine we played with many axiom systems or many variations on ones like the one I'm going to explain to you. And every one, but the one I am going to explain to you, had the interesting and unfortunate property that you could see without implementing anything. You could see just by reasoning that it wouldn't work, right? But this one, when you don't make even the slightest perturbation to any of the axioms in the way they're stated, does work. So what I'm trying to say is, whatever you think about this system of axioms, and whatever you think, oh, did it have to be that? Couldn't you have had that? We thought as well. And we discarded all the variations. So I'm just going to present to you the only exposition of the conceptual invention that we could see did meet the problem. And even now, we've not seen anything else that wouldn't. So here we go. EBR introduces the new non-schema object type called addition. So what do I mean by a non-schema object type? I'll spell it out, even though I expect you all know well enough. Before EBR came along, we had a clear example of that in the directory. If you want to have directories, someone's got to create them. Suppose Scott's going to create directories. You soon realize that there's no privilege. You can't go grant create directory to Scott, full stop. You have to go grant create any directory to Scott. That's the way these non-schema guys work. And then when Scott, empowered to create directories, has a go at creating one, he can't say create directory blake.d as blah, 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 blah. There's no such idea. The only thing he can do is create directory d as blah, 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 blah. The d is all there is to it. The d identifies the directory in the whole of the database. That's what we mean by non-schema. Now, who owns it when it's created? Nobody. It's just there in the database. Who can do stuff with it? Who can empower other users to use it? I expect you know the model. The person, Scott in this example, who has create any directory and who does create a directory ends up as a side effect with the privileges necessary to operate it in this case read, write, and execute, granted to himself with grant option. And then Scott can go grant read on directory D to Blake. If he likes Blake a lot, he could go grant read, write, and execute to Blake, all of them with grant option. That's not the syntax, that's the purpose in mind, yes? I'm going to assume you know all that inside out. And when I say that an addition is a non-schema object type, I mean exactly those properties that I just mentioned. What privilege do you need to operate with a directory? Turns out that there's only one, and for want of a better word, we call it use. So you grant create, the bootstrap, sys or system grants create any directory to Scott. Any addition to Scott. Scott creates edition E42. He finds he has the use privilege on it with grant option. Scott can then go grant use on edition E42 to Blake. Okay, simple. Why did we make it a non-schema object rather than having additions in schemas? Well, because this works and having it in schemas doesn't work with respect to the goal that we were meeting. As simple as that. A little bit of thought showed us that this worked and that's good, the other didn't work. So we've got this. Bear that thought in mind later on because it's critical. Next one, a database must have at least one edition. Why? Well, we tried what it would be like if it could have 0. We didn't like it, things broke. But things don't break when it's like this. So that's one of our axioms. It's the second one. You can guess there must be a DDL to create an edition. In fact, I spoke it out loud a moment ago. And you can guess there must be a DDL to drop an edition. There happens not to be one to alter an edition. If you can create editions and drop them, then there's a possibility, at least, that you can have more than one. You can't have fewer than one, but you can have more than one. If you've got more than one, how do they relate to each other? What's the relationship among them? And that's what the third bullet is. Rather than read out that third bullet or put it that way, let me word it a different way. When you have 2 or several editions in the database, then they all exist in a strict line, a strict linear succession from the one you had first, the most senior, to the one you created last, the most junior. And we just like to use the terminology of child and parent. So when you create an edition, it can only be created as the child of the previously youngest edition. Okay, simple as that. We talk about the parent-child relationship among editions. They're in this step by step along a straight line from most senior to most junior. But critically, as it says here, an edition can't have more than one child. It's not really that we ever thought of a tree. Rather, it's just we needed a string, and we naturally used the words parent and child. Why not? We could have used successor and predecessor, I suppose, and that would have given people less of a stimulus to think about children, many children, I don't know. Anyway, it is what it is. Why don't we let an edition have many children? Because that ties us up in messes in all sorts of situations, and having it simple and clean like this delivers what we want and doesn't tie us up in messes. So if I keep on hammering that, but I'm doing it because at every point along the way, people ask about that kind of thing. Or I will say this, even on film, worst case, you go to a conference at Birmingham or somewhere like that. I've seen this happen at Birmingham. Some random Oracle Ace director who thinks they can do a talk on something interesting. This was earlier when EBR was new. Read a bit of the docs, read mechanically about parent-child, create edition E as child of blah, blah. So they would get up on stage and say, I expect this is a temporary limitation, because they didn't have the internal view. And it's not in the nature of docs, really, to go on in prose, expressing all the sentences I've said in the course of the last 2 hours, No one would ever read it. But I'm telling you that so you know. It's not that we're thinking of changing that. It's one fundamental part of our axiom system, part of our invention. So then we're going to the next one here. A database session at every moment of its lifetime knows which edition it's using. And there's nothing unfamiliar about that. If you only think about current schema, you log on as Scott Tiger, your current schema is the schema owned by Scott. At any moment, you can say alter session set current schema equals Blake, right? You don't even need any privileges for that. If you try to operate on Blake's objects, it's only then that you need the privileges, just as if you said, you know, insert into table Blake.t, blah, blah, blah. It would or wouldn't work according to whatever privileges you had. The significance of current schema is that it sets the scope for name resolution, that and only that. Can you go alter session set current schema? I don't care, I don't want one anymore. I want no current schema. No. Why not? Well, I think some kind of intuition can tell you that would be stupid. It would lead to paradoxical situations. So it is with additions, right? You sign on and some mechanism, which I'll come to in the next point, puts you using some addition. If there's another one, and if you've got the privilege on it, you can go alter session set, we don't use the word current, alter session set addition equals E49. You know, simple enough. But you can't go alter session set addition, I don't want one at all. It's just not allowed. Why not? Because whatever, keep on saying. So that just implies something, if you think about it, because I'm implying that you have to specify the addition you want when you create a session. Because after all, it must be some addition, and who's going to know what it is? Well, obviously, we could not have said, when 11.2 came along, you've got to change the spelling of all your connect commands now, so that you mention not only username, password, but also the addition. That would be unacceptable. So that forces us, obviously, to invent a notion called the database default addition. And you can guess there's DDL to set it. And when you set it, it has to be one of the additions that's in the database, yes? Don't think that the default addition has any special significance when you're doing EBR, though. Rather, just think that we could not get away without introducing that simple notion. It has to be there for reasons of compatibility. Okay, then. So now, with that in place, let's see what that gives us, and this is it. I'll say this as briefly as I can, which implies that it's going to be slightly inaccurate, and then I'll return to the same sentences and make it more accurate, I should say. By being more precise, I can make it correct, where when I wasn't precise, it was a little bit hand-wavy and not quite right. So without EBR in the picture, an object is identified simply by two facts, its name and its owner. After EBR comes along, an object is identified by three facts, its name, its owner, and the addition where it's created. How do we know the addition? Well, that's obvious. How do you create an object? Create table, well, no, table's a bad example. Create view V as blah, 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 blah. Create package P, blah, blah, blah. You know, how do you do that? Obviously, it's a SQL statement. How do you get a SQL statement done? You have to be in a session when you issue such a SQL statement. What did I tell you about sessions? At every moment in their lifetime, a session knows the addition it's using. Therefore, when you create a view, it goes into the addition that you were using when you created it, right? Simple as that. So therefore, we know what the addition is. We know what the three facts are, even though you gave only two. The third fact, the addition, comes from the context of what you did. Now, why did I say that was not precise enough to be either right or wrong? It's too wishy-washy. For this reason, thank you, no one raised their hand and caught me out, but I'd have been ready for you, but I'll catch myself out now. Surely, you would be saying, you can have both a package called scott.x and a package body, both a package spec and a package body, both called scott.x. Yes. So you might be thinking, oh, he just left out a bit. The rule is really that the combination owner, object name, and object type, that must be unique. That might last you 5 or so seconds, and then you'd think, wait a minute, that would mean I can have a table called scott.t and a view called scott.t, because they differ in object type. If you tried it, you'd soon discover you can't, and then you'd realize, no, particularly if you just looked at the columns in DBA objects, you'd realize, the thing that I'm not naming properly is this concept called namespace. So there's a column in DBA objects called namespace, and if you go select distinct namespace from DBA objects where object type in, and then you list up synonym, view, function, procedure, package, type, maybe some others. The answer comes back as 1. All those guys are in namespace 1, and namespace 1, if you now reflect on it, is the namespace in which all the names must be found that you mention in an ordinary insert, update, delete, or select statement. It's kind of obvious, and maybe you've never thought about it this way, but you don't, while on the one hand you do say create view scott.v as blah, 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 create table scott.v as blah, 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 blah. The word view or table is in the DDLs. In the select, you just go select star from scott.v. And the SQL compiler, once it's established that this statement is syntactically correct, says, oh, I've got a V in my hands in the role of relation. What is that V? Ah, I see from the dictionary that it's a table. Oh, I see from the dictionary that it's a view. Yes? Make sense? So if you think about it for a moment and think of the source code that defines synonyms, views, PL SQL of all kinds, or if you think of the SQL that you do, insert, update, delete, or select, you're only ever mentioning names in namespace 1, and you're never mentioning the namespace or the object type. That's why I shorten my statement of rule to saying that an object is identified by its name and its owner. You know, I should say the objects that we're interested in the contexts of reference that we do, are so uniquely identified, right? In the larger database as a whole, and if we consider creating them, dropping them, and altering them, then there's more to it. Still with me? Right. So, in 11.1, name and owner is enough. In 11.2, it's name, owner, and the addition. And that's what you see in DBA objects, by the way, all those 3 values. However, when you do refer to an object, you identify it only by mentioning its name and its owner, optionally not even the owner in the famous way that we've always had. You can never explicitly mention the addition, right? You just can't go select star from scott.v as it is defined in edition E42. We gave you no such syntax. Why? It's not that we didn't think about it, because we worked out that everything that we needed to achieve with this apparatus can be achieved without that. And if we gave you that, it would simply give you an opportunity to dig yourself into all sorts of complicated holes and cause us, indeed, to have to consider all kinds of paradoxical situations in the implementation. So it was a simple decision. Don't need it. Having it would cause confusion at least, and at best paradoxes, therefore you can't have it, right? Don't worry too much about it. Just delight in the fact that by not needing to ever mention the addition, because you're not allowed to, you don't have to make changes in existing code. It'll just automatically work. The analogy is with the thought experiment we did for how to do zero downtime upgrade when you haven't got EBR, where you ended up really invading your source code and messing around with names. That would be a bad thing. Okay then, just to make sure it's crystal clear now, we already have set the stage. When you create a view, scott.v, you do so when you're using an edition and it's in that edition. If you're sitting in that edition, in other words, if that same edition, call it E42, is your current edition at select time, then you simply go select star from scott.v, and if there's many scott.vs in different editions, there's no ambiguity. We resolve to the one in the edition that's current when you do the SQL. Obvious, isn't it? No mystery there. Now take it one step further. Stored objects, synonyms, views, and PL SQL of all kinds, they exist, as I've just mentioned, in editions. Each goes into the edition that was current when you created it. Now, in the text of all these guys, you usually see references to other guys of the same kind. So if you go create view scott.v as select star from blake.w, where blake.w is also a view and might be in many different editions, which one among the many do you choose to be your dependency parent? Obviously, the one in the edition you're in. It's like the edition is a slice of the world and you can see everything in it from the point of view of name resolution and nothing outside it. That makes perfect sense, doesn't it? So there's no mystery, and you see, therefore, that A, name resolution will work without needing to mention the name of an addition, and B, we didn't allow you to mention the name of an addition in name resolution. Right then, so this point now is gold dust. This is the whole thing that organizes our... What happened there? No idea. My phone seemed to have some mysterious psychic effect on the screen. I just wanted to put it where I could see it. So then, this is the semantic model for create addition. And if you focus on this, it's so simple. When you create a new addition, then you do so in the environment of there being a most junior addition. If I didn't say it before, we always refer to the most junior addition as the leaf and the most senior as the root, as if we had trees. It's the same vocabulary of trees, but remember, we've just got a straight line. So when you create an addition, you do so by creating it as the child of the previous leaf, so that the previous leaf becomes the parent of the new leaf. And at the moment you do that, the previous leaf, the leaf that's going to become the parent of the new leaf, has objects in it, views, synonyms, and PL/SQL. So those objects are simply semantically copied, bang, into the new addition, just like that. And thereafter, those two sets of objects, each in its own addition, live their separate lives. Okay? Simple. I mean, how hard is it to understand that? It's a very clear statement. Notice that I've used a term of art there. I've said every additioned object, blah, blah. And I haven't defined that term of art for you, and I'm not ready to. You just have to kind of let that little bit of uncertainty linger and enjoy a sense of deferred gratification. It'll come true, but I'm not ready to gratify you yet. So moving on then, thank you for not exploding when I said that, but in previous talks, particularly when there's a high density of people who call themselves DBAs, they're already having a kind of what we call hissy fit at this stage, because they're saying, what, e-business suite, it's got 10,000 objects, and you're telling me that when I create a new edition, each one of them will be copied. Oh, it'll take too long. Oh, it'll take too much space in the dictionary. Oh, everything will go bad. Or system table space, blah, 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 blah. I can't bear it. So anyway, I already told you the answer. I said that our non-functional requirements included the idea that creating a new edition be instantaneous. So how do you make something with a full semantic effect like that be instantaneous? We invented, brought brand new to computer science, the idea of copy on write. No, I wish I could say that. We stole it, we adopted it, we embraced it. Obviously, it's a well-known idea to achieve that effect. So this is what I'm carefully calling the mental model of the implementation. Here's our starting point. We've got a view, a synonym, a PL/SQL object of a couple of kinds. They're all in the current leaf, which I've called there the pre-upgrade edition. Now, in order to do our upgrade, we create a new edition. It must be the child of the previously existing leaf. And now we've got that situation. And you see, obviously, what happened was in fact nothing, but we've got a rule. And that is that if object 1 was a view and you go select star from object 1 while you're using the new edition, then we say, right, I understand I'm looking for a relation whose name is Scott.object1. Let me see where it is, and then I can see if it's a view or a table. Oh, I haven't got one. It's not instant failure. You think, well, I haven't got one. Maybe I know someone who has. Look back one edition. Is it there? If not, look back another. Is it there? On and on till you find it. Very obvious notion of inheritance, right? Now, even then, these DBAs, so-called self-identifying DBAs, would be panicking. Well, that's going to be slow then. Obviously, the more editions I have, they don't bother to think that might be quick, even though you're doing that, and they don't bother to think that it only happens at name resolution time, and name resolution time is only done at compilation time, and the last thing you do is compile all the time when you're running. They don't joins those dots. They just think, oh, hop, 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 look, 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 fail, bad. Well, just to let you know, that's the mental model of the implementation that's adequate for your normal purposes. There is a real implementation, and that's, not surprisingly, something along the lines of Unix links. So when you create a new edition, you actually, behind the scenes, create what amounts to a link to every object that you're trying to copy, who's just a straight pointer to it, okay? If you look around for those links, there's no evidence of them in the documented dictionary views. It's as simple as that. If you're the kind of nerdy person who likes to investigate things and then blog about it or talk about it at Oracle user group conferences, it wouldn't take you long to work out that there are rows in obj$ who are not advertised in these documented views who implement these magical links, okay? You don't need to know that, but maybe if you do know it, it'll make it seem not mysterious in any way. It'll seem just completely ordinary and obvious. Okay then, and we use the vocabulary that's suggested by the picture. Those white objects are all inherited, while the red ones are actual in their edition. And then, of course, we do create or replace object 1 as blah, 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 and we change it to be what we now want it to be. And we do the same on object 2. And now they have those stars upon them, meaning that they are both identified by the same owner and name. Nevertheless, each has a different physical incarnation representing the difference in the definitions, and that's what the stars are, and they can be there both at the same time because each in its own edition, yes? And now, object 1 and object 2 have become actual, or they've been actualized, yes? Still with me? So then, what next? Well, obviously, you can drop an object, and it's gone in the new edition and still there in the old edition. Now, at this stage, even if you're not thinking it, I'll think it for you. The question arises, what happens if I decide to do DDL on that? And the answer that I've suggested to you is that as a side effect of doing that, then you'll get actualization here of object 3 as it used to be, so you'll get object 3 star there. Given what I said, that the mental model is exactly that. The semantic model is exactly that. Just it's as if you had created a copy of everything and it's now there, so that the two worlds can lead their independent lives. Then yes, sure enough, you would have concluded that I ought to be able to do object 3 star in the parent and leave object 3 unchanged in the leaf. Now, if you did the experiment, just one second, on your own private laptop, exactly what I've shown on the screen, you would find, oh dear, when I do a change in object 3, it shines through into the new edition. If you then troll the bug database, you'd find that we consider this as a bug, and the bug has been open since actually before EBR was even productized in 11.2. We would like to fix it, but it's hugely difficult to fix for various reasons. We presently will. Why are we relaxed about not fixing it? I'll come to you in a second. It's because of that larger principle that I insisted earlier, that you would never do DDLs in the live edition. We sometimes call that the run edition. If you could do that, you wouldn't need EBR. And it's not safe to do that. So we have EBR. So when you're using EBR, to be safe, you do all the DDLs that you're going to do in the new edition. So the question, what would happen if I changed, what would happen if I did DDLs on that, is theoretical only. You're never going to do it, and therefore you're not going to suffer from the bug. Okay? Now, your question?
Yes, it also related to that. But if you need to do a patch on the parent edition
yes.
for object 2, and
yes.
you have already created the actual in the new edition,
yes.
will it say anything about that we have a relationship that is more or less
yes.
broken down or something?
Right.
Yeah.
I understand the question. I'd better take some advice now. I could complete the answer to that and do it in quite some detail and complete this episode at 12, or kind of find a way to round this off and come back to that after lunch. Which would you prefer? You're in command. Do we have the ability to flex, or do we have to stick?
Take it after lunch. Yeah.
Okay, take it after lunch. In that case, don't forget that question, And it will introduce me to say two rather different kinds of speech, both which are rather like the ones I've been doing so far. You can imagine, yes. So hold that thought, don't forget it, and we'll come back to it. So what I will go on to say now then is that given what I've explained to you, you have a complete apparatus, without me explaining the rest, for a certain class of problem. Now, before, I talked somewhat uncharitably, but very justifiably so, about this bag of tables world, right? This is where the database is nothing other than tables and presumably indexes, but usually in that paradigm, not even constraints of any kind. Strange. The other end of the one, of course, is the full-on hard shell, the smart database approach, where the only items that the outside world, the clients to the database, see by construction is a smallish number of PL/SQL functions or procedures, exactly the set that define the functional API for this whole business proposition in the database, right? Now, then there'll be tons of tables, but all the inserts, updates, and deletes and selects that operate on the tables will be coming out of PL/SQL code, right? Now, if you've got that regime, a couple of things are true. One, it probably shows you've got good brain power because you didn't go near that rubbish model. And given that you've got good brain power and you've got all this PL/SQL, it also implies, by the way, that you did your table design properly because you're that kind of good brain power person. So you'd never have fallen into that attribute name, attribute value trap. So the impotence to sort of, in inverted commas, patch the data model is rather seldom. You'd only want to do structure changes among the tables when genuine new functionality is coming along. That means that a typical patching requirement might well be met by making changes only among the definitions of PL/SQL views and synonyms in the database. And in the most favorable case, it's entirely that meets your goal, while the outside of the database code is unaffected. Just think about it. You put a huge intellectual effort into defining a crisp, functionally oriented, and terse API. That's the contract between the outside world and the inner world. That contract is not going to need rewriting in the face of patching, is it? It doesn't kind of make sense. You had the intelligence to do the contract right. You might need to extend the contract for kind of significant semantic upgrades, but for ordinary patching, the contract is the contract. Therefore, if you've got bugs in the code in the database, which of course you're likely to have, you can fix them without needing to change the contract, without needing to inform the outside world. Okay? Got that? So I'm saying here, if you're that kind of shop, you can make a first level adoption of EBR and stop there and still be well satisfied. And I know people who've done this. They don't bother with the rest of the apparatus. And when it comes to do table changes, they do it once a year and they do take downtime for that and they don't mind, because what they are able to do is make changes among the PL/SQL, your kind of hot patch thing, incidentally, all the time, whenever they want it, with no fuss or bother, using EBR. And that makes them happy. What does this say? Zoom detects there's a problem with your audio. If you enter your Mac computer password, we will attempt to restart the audio. Oh my God. I'd better do this, but don't you hate it? Yes. I mean, what do you think would happen when your autonomous car says, we have detected a problem. There seems to be a brick wall and we seem to be driving into it. Please enter your password. Yes. So I don't know where that leaves us on the recording, but we'll muddle through. So now we've got an interesting question, because if you go back to this, if I can get back there quick enough. Oh. You know what? Yes, here we are. Remember this? Of course, how could you forget, right? What I'm saying is that, though I didn't use those words, I'll now say it. Once a session is established and it was set up to use a particular edition, it remains using that edition forever. That's what this picture shows. And the way you take advantage of the new edition is by deploying a whole new set of the middle tier stuff and just configuring it once and for all so that for all time uses the new. So I seem to be saying, if that's the model, that in this patching of only PL/SQL, where the outside world stuff needs no change, then what's going on here? Something is completely messed up with the scrolling stuff. I'll just have to do it without the slide, and we'll fix that glitch after lunch. I seem to be saying that you, even so, in order simply to take advantage of the new edition that exposes the proper working PL/SQL, you have to do that whole dance with the middle tier and the traffic director. Now, there's two schools of thought there. One, which is, well, yes, just do that. Because after all, if you have a mechanical procedure to do that kind of thing, it's simpler just to have one procedure. It's mechanical. How hard can that be? Just run it, job done. Don't fuss about it. But there are others who just feel, no, I can't do that. I want it to be magic and mysterious inside the database so that the outside world doesn't even know I'm doing anything. I don't have to speak to any other people, anything. And so the question is, how can I flip an in-flight session from one edition to another? And the answer is, there are ways to do it. If you are full-on hard shell, it's remarkably easy because you are the bottleneck into the database for everything. If you're putting raw selects into the database, there's no kind of thing you can latch onto. We don't have a onSelect trigger. Let's just describe how it would be if you are the sensible kind of person who is using the hard shell, and then we can stop. So in here, you just need to write one procedure, and you make it available. You call it in each of the top-level things that implement your API, and only those. This is what the procedure does. It looks in a table. What table? A table you've invented for the purpose. The table is a one-column table with one row who has the name of the edition you ought to be using at the moment, right? And then you have a a result-cached function who gets that name out of the table. And then in this P, this procedure you write for the purpose, it says, what am I supposed to be using? Then it says, what am I using? You can guess syscontext user env current edition name. Is what I'm using what I'm supposed to be using? Yes? No. No, I'll flip. Now I said alter session set edition. You'll discover if you try it that that is illegal during an in-flight session. If you went begin execute immediate alter session set current edition equals blah blah, you'd get an immediate runtime error saying we don't allow you to do that. But what we do allow you to do is say you'd like to be in a different edition in your next server call, deferred. And we've got dbms session set edition deferred. So if you call that in this procedure P, when you notice from your table that you need to flip, then next time you come in, you will have flipped. Job done. Simple as that. One little detail, packages have state. If you've got two packages with the same name and owner, but in different editions, then if you touch one in one edition and touch one in the other edition, each one in your foreground has its own representation of the state. Now we're leaving the state of the package in question orphaned, adrift in the old edition. So just before leaving, we would also do this dbms session set, what's it called? Reset package state. You know that one? So that this P, it's not hard, is it? You can see it there. Get what I'm supposed to be using. Ask what I am using. If they're the same, do nothing. Otherwise, flip deferred to the new edition and wipe out the package state, job done. So you can easily see how you could invent your own method and implement it and perfectly happily flip all things over so the outside world doesn't even know you did all this, and that's quite an appealing idea. We'd have to find some way of 1146 uniting that idea with the service name and stuff that I talked about before, and I don't think I said it clearly enough before, so now I will say it because all the pieces are in mind. New in the version of the database that brought EBR, a service has among its properties one called initial session edition. That never used to be there, now it is, and it is exactly what its name says. So in my story about the 5 facts and the 5 facts, if you look closely, you'd see Listener port and location, the same in both cases. Username and password, the same in both cases. Service name, different in both cases. Compare the service definitions, identical, identical, identical. Oh, I see, the initial session edition is different here and there, right? So a session starts in the edition that you specified in the service, and then you specified it, and it's there. Now, how do we that's the model you would use in the pink-blue kind of scheme. In this flipping scheme, it seems that we're kind of overriding what the service says, and that there'd be an awkwardness between the two. I won't give you the full detail, but you can make it all work if you just bring in another idea. If this table that tells you where you're supposed to be is null, well, you know you don't do anything under all circumstances. So with a bit of discipline, you can arrange things so that for this patching situation that's met only by changes within the database, you can auto-magically flip things so that the outside world isn't recruited. But when there's a real semantic change and you need the red and the gray, you can arrange it so that works out too.